And we're live. Welcome, ladies and gentlemen. Welcome to the third day of Avant of Code, everybody. I've got my Christmas hat on. I've got my Christmas tree set up. Did that a couple of hours ago. And I'm really into the Christmas mood, the Christmas vibe, as AoC is in full swing now. So I'm excited to see what Eric's got in store for us today. Yeah, let me just go into my environment as I usually do. Oh, and I've got all my solutions now up on GitHub, so you can check the description down below if you want to see my code, refer back to it, I don't know. But yeah, let's just check what my files I've got. Oh yeah, one thing I wanted to do is actually just keep my input code ready, since there's no point coding that up. It's the same code every single time, and it just wastes my time. So that looks right. Right, I think I'm ready to begin. Okay, let's start straight into day 3 in 3, 2, 1, go. Okay, yes, that was good. I got the right answer. That's pretty fast, and I really like that. Closer to getting enough star fruit. Yeah, probably should have been listening to the storyline, but let me just copy my file for day 3 part 1, and I'll move on to day 3 part 2 right after that. See you after time lapse. Awesome. I really like that day. That day was epic. Yeah, got the right answer. That was really fast. Let's go through the problem and then I'll see how the people on the leaderboard did. And I'm wondering if I can compare myself to them, just maybe. Yeah, let's go. Nope, let's not look at that. First we need to look at the day. You're right. Day 3, rucksack reorganization. Oh dear, this reminds me of Avant of Code 2020, day 7, where they had a ton of nested backpacks and you had to do recursion, and that's the first time I've ever done recursion. It took me an hour, and it was not fun. Bad memories. Anyway, one elf has the important job of loading all the other rucksacks. Okay, Eric doesn't think all of us know what a rucksack is. All of the other rucksacks with supplies for the jungle journey. Unfortunately, that elf didn't quite follow the packing instructions, and so a few items now need to be rearranged. Each rucksack has 2 large compartments. All items of a given type are meant to go into exactly one of the 2 compartments. The elf that did the packing failed to follow this rule for exactly 1 item per rucksack. The elves have made a list of all the items currently in each rucksack, your puzzle input, but they need your help in finding the errors. Every item type is identified by a single lowercase or uppercase letter, and as A and A refer to different item types. These elves are really unreliable. They're not good. Santa needs new elves for next year. But anyway, the list of items for each rucksack is given as characters all on a single line. A given rucksack always has the same number of items in each of its 2 compartments. So the first half of the characters represent items in the first compartment, while the second half of the characters represent items in the second compartment. For example, suppose you have the following list of contents from 6 rucksacks. Blah blah blah, this is an example. To help prioritize item rearrangement, every item type can be converted to a priority. Lowercase items have priorities 1 to 26, uppercase 27 to 52. In the above example, the priority blah blah blah. Find the item type that appears in both compartments of each rucksack. What is the sum of the priorities of those 2 item types? or those item types. Yeah, so I mean, I did read the last sentence here initially when I was solving it. That clearly wasn't enough, but I think looking at the puzzle, like this example here, and then just looking at a couple of these, and like especially this bit, this was really helpful. But I think like the key bit that you had to see, that you had to recognize, is this stuff about compartments somewhere. This stuff, yeah, the first half of characters. And once you've seen that, you can just extrapolate the fact that the second half is going to be the second compartment. But I think, yeah, just imagine trying to skim read this to just really just extract this single line. Quite annoying, but I guess that's the fun of it. Trying doing it fast. But yeah, let's now go move on to see what I put. That'll be Vim Day 3A. Right, and zoom in for you guys. Let's make this a bit bigger. Yeah, just opening the file as usual, splitting on the lines, classic, keeping the totals and the answer. Now here's a good one, line 5. This is just like from the module string you can import these two things, and they are just like a string. Each of them is a string of ASCII uppercase and ASCII lowercase letters, just all in a row, the alphabet, A to Z. Really useful, instead of trying to type out the letters yourself. And then what I do is have to go through each rucksack in the input, and this was the line, pretty important line. Here, I'm just A and B are the two compartments of the rucksack, so I'm just taking the first compartment here and the second compartment here. And the way I do that is just by using like a slice. So I just slice it halfway through here and halfway through here. I think that was like a pretty fast way, which many people may not have done. But yeah, and let's see. And I'll just go through for every item in A. If it's in the first compartment, check if it's in the second compartment, and if it is, then do the stuff. You can probably use lists, or sorry, sets, to check if they're both in the same, if like the same letter is in both compartments. I don't know, I just didn't think sets would be like needed, right? I mean, I use sets in the second part, we'll see about that later, but I don't know, this was faster for me to write, I thought, and I was not like perfectly sure on the set commands, so just thought this would be better, although yeah, it'd be inefficient. Yeah, so then I check if R is like lowercase, because you can't, one of the issues with Python is you can't like use this index command on something that doesn't exist in the list. So if R didn't exist in ASCII lowercase, it throw an error, which really sucks. But it means that I just have to check if it says lowercase. If it isn't, then I'll just do the uppercase equivalent of the command. And you know, this just grabs the index of where R is in the alphabet. So I'll grab an index from 0 to 25. But you want to like start from 1, which is why you just have to add 1 to the index for the lowercase characters, it says here. And then for the uppercase characters, they start at 27. So you need to add 27, because A, which is the first item in this list, that has a priority of 27. So you have to add 27 to the index. And yeah, after you do that, you just add that number to the running total of the priorities, because it says you want the sum. So you do that with T, and then you just print it. And I think one thing that I feel like people may have messed up on is this break, because I don't know, I just feel like, what if, I don't actually know, to be honest, if I needed that, because I didn't really read the input, but like, if for example, the letter B is in both the first compartment and the second compartment, but it appears twice in the first compartment, then this fine, this will run as normal for the first time, but as you continue going through the first compartment and there's another letter B in it, even though you've already checked that letter and it's already in both, you're fine, you've already added the total, it's going to do the exact same thing again. So it might just end up with duplicates or even like triplicates or whatever. So I guess just breaking there, no harm done, probably makes my time faster. Gives the right answer. Actually, does it even change the answer? Let me check. 11054. Yeah, so it actually does change the answer. Yeah, I did not know that. So I guess in some cases there would be duplicates across a compartment, which would really mess the code up. But yeah, anyway, that was my code. Let's move on to part 2. As you finish identifying the misplaced items, the elves come to you with another issue. These elves, man, they just issue after issue after issue. For safety, the elves are divided into groups of 3. Each elf carries a badge that identifies their group. Proficiency, within each group of 3 elves, the badge is the only item type carried by all 3 elves. That is, if a group's badge is item type B, then all 3 Ls will have item type B somewhere in their rucksack, and then most 2 of the Ls will be carrying another item type. The problem is that someone forgot to put this year's updated authenticity sticker on the badges. All of the badges need to be pulled out of the rucksack so that new authenticity stickers can be attached. By this someone forgot, you probably meant an elf forgot, to be honest. Additionally, nobody wrote down which item type corresponds to each group's badges. The only way to tell which item type is the right one is by finding the one item type that is common between all 3 Ls in each group. Every set of 3 lines in your list corresponds to a single group, but each group can have a different badge item type. So in the above example, the first group's rucksacks are the first 3 lines, blah blah blah. Priorities for these item bags to organize sticker attachment methods. So same priorities as before. Want the item type that corresponds to the badges. Find the item type that corresponds to the badges of each 3 elf group. And what is the sum of the priorities of those item types? Yeah, I mean, thankfully I read this last sentence first when I was solving it. It seemed to be like a similar idea with adding the item type. Then I saw this priorities word at the start of this paragraph. Yeah, I mean, it doesn't say anything new about priorities, so I just correctly made the assumption that the priority method is the same. And in this, I think it was pretty easy to figure out what this meant fast, because the only item type carried by all 3 Ls, that kind of tells you all you need to know. So my next question would be, what are the 3 Ls? And then like, first thing I looked at the input, like the example, and right above that it just said, every set of 3 lines corresponds to a single group. So that was a good way for me to figure out quickly. But anyway, yeah, let's go on to my solution to see what I did. Day 3b.py. Zoom in again a bit more. So same thing as before. What changed here is this line. Instead of what I did before, I went through every item in X, my puzzle input. This time I'm going through every set of 3 items. So I start off with 0, and I go in increments of 3 lines at a time. That's just a really handy way of trying to group 3 lines together, because you're ranging through the index of each line, but only every 3 lines. And so that means that you have your given line here, which is xi, and then the next line would be xi plus 1, and the next line would be xi plus 2. And so like these are the 3 lines that you're given, or that this code goes through per loop. That's what I do here. I just grab the 3 lines, turn them into the strings A, B, and C. So A, B, and C are just my 3 lines, 3 elves. And then here, so in the previous question, I did choose sets. I didn't think it would matter for speed, and it didn't. It's faster to write as well. But here, like these, I felt like this would take longer, because you're not just comparing half of each line with the other half of each line. You're comparing 3 entire lines together, and not only would that be a hassle to code, it may also take a while, like a long runtime, and I wasn't going to risk that. So I turned them into sets here, and I just checked. I checked for all the common items between A and B, and then checked for all of the common items between that and C. Just using the set intersection method. So checking which items intersect between the 2 backpacks, and then turn that into set A. And then of those sets, like of that set, so of the items that are both in elf A and B, how many of those are also in set C? And then since Eric said in the question there's only 1, that should be shared among all 3, we know that A is just going to be a set of just 1 character, 1 string, 1 letter. But to like harness that letter, you can't just like reference an index of a set, because a set doesn't have indexes. That's the whole point. It's a hash table. Sorry, it's not a hash table. It's just a random grouping of numbers. So got to turn that into a list, and that makes it indexable. And you just index the first element, which is the only element in theory. And then you do the same thing as before, just to figure out what priority you're going to add, and then you print that. Yeah, because of the way I structured this program compared to last time, I think no need for like dodgy breaks and things like that to try and like squeeze out the edge cases. This works. This is much more mathematical, probably the cleaner solution. because I use sets. And yeah, sets are really fast. In Python, if you can use a set, do use a set. But yeah, that was the code. It worked, which is quite nice. Yeah, I think that's it. Let me just upload those to GitHub. Actually, I'll do that later because I don't want you guys to see my GitHub key. 2 gold stars. Oh god, let's see the calendar. Yeah, that's nice. Ooh, what could this be? Like, maybe some maize coming up? Oh, this is probably a C again. I don't know. Reminds me of the dragons. I think they were last year. No, the year before that, yeah. 2020 had the dragons, the sea monsters. Anyway, yeah, got my 6 stars right up here. All on time today. Next challenge is 6.5 hours. Again, not waking up that early. But yeah, let's check out the leaderboard. Right, all time. Oh, Ben Alvarez still in the lead. Classic. Oliver doing well. Yeah, this is nice. Oh, Jonathan's only 17th. I'll check out his YouTube video later. Nimcast still up here. Nice. Yeah, let's see what their speeds were. 3 minutes, damn. 10 seconds. 10 seconds. Okay, so it must have been a really quick. I don't know, this guy had some code, some AI to do it. I don't know. 10 seconds though. Did he just really quickly realize what the question is asking? No way though, because part 1 is harder to understand than part 2, in my opinion. Ooh, this guy, something's going on here. 10 seconds. He must have figured out the question really insanely fast, and then just wrote out some maths to do it really quickly. Because I guess if you use like a functional or an array-oriented language, I guess maybe using maths would be much faster, like APL for example, or maybe Haskell even. Anyway, part 2. Yeah, this guy took a bit longer for part 2. Still incredible. 2.5 minutes. 5 space. Yeah, I mean, this 5 space dude probably. Yeah, he must have done it in a way that meant doing part 2 was really quick. Later, I remember him. He was good last year. Yeah, let's see. Slowest part 2 is 5.5 minutes. Damn. Yeah. Leaderboards getting competitive this year, but I think these are some good times. Awesome. Let's check out the private leaderboard. Ooh, okay. Abraham's dropped down to 7th. I know he woke up late today, which is funny because he was first just yesterday. So he's 20 points behind now. Wow. Nice, nice. A lot of people have done day 3 to be fair. Like 41 people in total. That's nice, that's good. And I think that's more than previous years in our school as well. I see Mr. Attenborough's also got the AC++ badge. It's just teachers and me. Let's see. Annabelle's doing something funky. Not doing day 1, but doing day 2 and 3. Anyway. Oop. Ardy got silver medal. That's good. Yeah. I see Mr. Gold was a bit slow. Delta times for day 3. Nice. These are good times. I mean, how was I faster than everyone else? Oh well. Yeah, I think it's just a matter of reading the problem statement faster, to be honest. But yeah, these are good. Yeah, quite happy with the leaderboards. They're good and interesting as well. Oh, let's check if there are any global points. Yeah, Anonymous has got 1 global point. Did he come like last place in part 1 or something? Yeah, he did. Wow, that's good. Quite funny. Look at that. Split seconds between 1 point and no points. But nice. Well done to him. Congrats. But yeah, I think that's it for today. Hopefully you also got the 2 stars in the day. Thankfully today was nice and easy, which makes me suspect tomorrow's not going to be. But we'll see about that. That's a tomorrow problem. Our calendar's looking nice. These appear to be trees now that they go green. Oh well, I guess we'll see in the next few days. Have a good Christmas. Enjoy December. Enjoy Advent. Enjoy coding. Goodbye.